ESA revives old spaceplane concepts, Space Pioneer gets ready to fly its Falcon 9-like rocket 1 year after it accidentally lifted off, Relativity's Aeon R engine breathes fire, and Artemis progresses on many fronts. We'll have all that and more coming up this week in Spaceflight. NASA is testing the SLS rocket for the upcoming Artemis II mission, which will send humans around the moon for the first time since the early 1970s. Most of the rocket has been built in the Vehicle Assembly Building at the Kennedy Space Center. We followed that process as it happened in the first half of this year. With the rocket now mostly complete, NASA is putting it through its paces to ensure everything works as intended. The agency even made a checklist of 10 tests it has to pass before it's allowed to leave the building ahead of its wet dress rehearsal. This week, NASA completed one of these tests involving the solid rocket boosters, during which teams verified they communicate with the ground systems as intended. Most of the tests on the list are similar, running through procedures, testing connections, and interfaces between all of the parts. As NASA gets closer to the launch, the tests get more exciting. The penultimate test on the list involves the Artemis II astronauts rehearsing all their launch preparations before driving to the VAB to board the Orion capsule. With all the tests inside the VAB complete, SLS will roll out to the launch pad for a wet dress rehearsal. During that test, teams will go through the full launch countdown without the astronauts and without launching at the end, of course. In other SLS news, Boeing made a square or something? Ryan, what's up with that?
Boeing is expected to spend $2.8 billion on NASA's brand new exploration upper stage, so why did they just post a virtual rendered square as progress? Here's the deal. The current Space Launch System configuration relies on the Interim Cryogenic Propulsion Stage, or ICPS, built by United Launch Alliance. The ICPS, essentially a modified second stage from ULA's Delta rocket family, is tailored to work with the Orion spacecraft for the first 3 Artemis missions. As its name suggests, the interim part is key. It's a temporary solution, a placeholder until a more capable successor takes over. The ICPS has proven its abilities on Artemis 1, providing the necessary thrust to propel Orion into lunar orbit. However, its limitations in power and payload capacity make it inadequate for the more ambitious goals of Artemis 4 and beyond, which aim to deliver heavier payloads, including components for the Lunar Gateway space station and sustained lunar surface operations. Enter the Exploration Upper Stage, the next-generation powerhouse designed to replace the ICPS, starting with Artemis 4. That's what Boeing is working on at NASA's Michoud Assembly Facility. It's one of the upgrades coming to the SLS rocket in its new Block 1B configuration, providing a boost in payload capacity and a stretch to the rocket's height that also necessitates a brand new launch platform. This week, the company announced it completed the first thrust structure for this stage. It connects the 4 RL-10 engines to the rest of the upper stage and transfers the loads or thrust from the engines to the rocket. That's an upgrade from the single RL-10 which powers the ICPS, and if you really want to get into the details, technically the engine itself will also be upgraded from the RL-10B2 to the RL-10C3. So here we go, finally some good progress with EUS flight hardware. Well, no, the completed piece is not meant for flight. It's for the structural test article that will be tested to ensure it meets all of NASA's requirements and transfers the thrust in a way that doesn't damage the upper stage. But Boeing did say it's already working on the first flight-worthy thrust structure as well. Now, here's the thing which has been generating all the fuss on social media. Weirdly, for whatever reason, Boeing didn't actually share any pictures of the completed thrust structure, but instead just some computer-generated images showing what it would look like. So we'll have to trust them that they actually built it. But why didn't they share it? Perhaps it's outfitted with something proprietary, or maybe Boeing forgot that a square is a basic geometric shape and that they thought it needed protection from public eyes. It's anyone's guess, really. Despite the odd PR choice, Boeing's progress on the EUS is a positive step for the Artemis program. The recent passage of the so-called Big Beautiful Bill by Congress has secured the SLS program's future through Artemis 5, silencing earlier uncertainties under the current administration, which had considered cancelling SLS after Artemis 3. Moving forward, Boeing's ability to deliver and perhaps show tangible progress will be crucial. For now, we'll just have to trust their word on the thrust structure and hope future updates come with real photos, not just rendered squares. Sawyer, back to you.
Thanks, Ryan. One of the things that will play an important role in future moon missions is a lunar terrain vehicle. Astronauts will use this vehicle to drive around so they can cover greater distances while exploring the lunar surface. Now, this concept is nothing new. The last 3 Apollo missions brought the Lunar Roving Vehicle, also known as the Moon Buggy. The astronauts used it to drive nearly 36 kilometers on Apollo 17. So, the Moon Buggy is making a comeback on Artemis as the Lunar Terrain Vehicle, or LTV. Currently, there are 3 companies in the race to build it. There's Astrolab with its Flex rover, Intuitive Machines with the Moon Racer, and Lunar Outpost is working on a rover named Eagle. NASA plans to award a demonstration mission to at least one of these rovers by the end of the year. Unlike Apollo's Moon Buggy, the LTVs won't just carry astronauts. They're all designed to be operated remotely. This way, NASA can continue exploring the moon between missions. Very clever. The agency has now selected 2 instruments that will be mounted on one of these rovers. First, there's the Artemis Infrared Reflectance and Emission Spectrometer, or ARES for short. It will hunt the lunar surface for minerals and volatiles like water, ammonia, and carbon dioxide. To do so, it will map the moon using its visible light camera and a spectrometer. The other instrument is called LMAPS, which stands for Lunar Microwave Active Passive Spectrometer. And yes, that's another spectrometer. Scientists really like them. This one will be used together with a ground-penetrating radar to figure out what's below the surface. The instruments will measure temperature, density, and subsurface structures down to 40 meters below the surface in the hopes of locating ice. But wait, there's more! NASA selected one additional instrument that won't be fitted to a rover, but will study the moon from orbit instead. Guess what? It's also a spectrometer! The Ultra Compact Imaging Spectrometer for the Moon, or UCIS Moon, will map the region from above to provide more context to the discoveries made by the LTV. The astronauts driving around the moon on their 21st century moon buggy will do so wearing a spacesuit. I mean, they can't live without one, really. And that suit will be built by Axiom Space, which is working on its AX-EMU suits, or the Axiom Extravehicular Mobility Units. This week, the company announced that it's partnering with glasses manufacturer Oakley on the visor for these spacesuits, and they are up for quite a challenge. One of the biggest problems to deal with is the lack of atmosphere. That may seem obvious, it's really at the root of many problems that the company needs to solve, but it means that the light on the moon is brighter and harsher, while the shadows are much darker than we're used to here on Earth. Plus, the lack of air means that light bends differently, just like how water changes how light bends. Now, despite all of these challenges, the visor should provide the astronauts with a clear view of the moon. So to that end, companies designed a 2-part visor that slides out of the way when required. Just like the visors used by the Apollo astronauts, the one designed by Oakley and Axiom is coated with gold to block the brightest light. Underneath, the Artemis astronauts will wear a helmet bubble that protects them from UV radiation and lunar dust. All this should give the astronauts the best close-up view of our celestial companion. And with more news about Artemis every week, it really feels like we're getting closer to seeing these missions become reality. Intuitive Machines and Space Forge have announced a strategic partnership, which is designed to ignite the manufacturing of semiconductors in orbit and fuel the development of re-entry technology that will bring these and other products back to Earth. Using a grant from the Texas Space Commission, Intuitive Machines is working on a prototype Earth re-entry vehicle called Zephyr that is designed to return products manufactured in space. The first 12-month phase will take the spacecraft through initial development, critical design review, and the construction of a full-scale mock-up on the ground. SpaceForge, meanwhile, has developed cutting-edge production of semiconductors in microgravity, which will be used to create high-purity substrates. These crystal seeds can then be used to grow larger crystals that will then be used to create ultra-efficient next-generation computer chips. SpaceForge joins pharmaceutical company Rhodium Scientific, which already joined the program in April and specializes in biomanufacturing in space. So what are the benefits of manufacturing in orbit? Certain materials, alloys, and pharmaceuticals can be more efficiently produced in space or exhibit unique properties that are simply not possible here on Earth. Microgravity prevents buoyancy, which allows for the perfect formation of larger seed crystals, which can then be expanded back on Earth into wafers and chips without defects. With greater purity and uniform structures, these products will be significantly higher quality than those we can produce here on Earth. These semiconductors could have big implications for next-generation computing, from data centers and telecommunications to potentially cutting the time it takes to charge an electric vehicle in half. With the ambient pressure 10 trillion times lower in the vacuum of space, contamination issues are also negated and pumps are more efficient, for example. There's also no need for cryogenics for ultra-fast curing because temperatures of near absolute zero are naturally available thanks to the cold environment of space. Spaceforge's first satellite was unfortunately lost in early 2023 aboard what would be the final flight of Virgin Orbit's Launcher 1. The launcher experienced an anomaly with its second stage engine, resulting in Forge Star 0 and other payloads failing to reach orbit. More recently, Spaceforge launched the UK's first licensed satellite for in-space manufacturing at the end of June aboard SpaceX's Transporter 14 mission. Forge Star 1 has been 4 years in the making and was developed entirely in Wales before being shipped to Florida for integration. The satellite is currently undergoing health checkouts and will soon prove the viability of in-orbit manufacturing by conducting a number of experiments in the unique conditions of space. You can bet we'll be keeping our eye on this story as these companies forge ahead. And if you want to stay up to date, well, you know what to do. Subscribe to our channel and hit the notification bell. And if you like our show, there's a button for that too. The Chinese commercial launch provider Space Pioneer is preparing for the maiden flight of its Tianlong-3 vehicle. You may remember a not-so-static fire of the rocket's first stage, which the company conducted a year ago in late June 2024. The stage unintentionally broke free from the test stand and flew into the air before crashing into the nearby mountains near Gangyi. This was traced to a structural failure in the stand's anchoring mechanism, which wasn't designed to hold down the amount of thrust generated, but also helped identify other structural issues on the vehicle itself. Well, the company has bounced back over the last year and has been very busy validating over 100 modifications to the first stage engine section and the overall structure and systems. Load testing has now verified these upgrades, and the first vehicle was assembled in late May. The second stage has been prepared for some, hopefully, less dramatic static fire tests of its vacuum engine aboard the company's floating Haas test platform at the Haiyang spaceport. The test will verify engine relighting and full duration burns. Meanwhile, the company has been developing launch infrastructure, such as the transporter erector, at its own facility within the Jiuquan Satellite Center, where the rocket will make its debut flight. Space Pioneer became the first Chinese private company to successfully launch a fully liquid-propelled rocket to orbit on its first attempt with the Tianlong-2 in April 2023. Tianlong-3 is one of several commercially developed rockets that are now expected to make their debuts in the second half of this year. These also include LandSpace's Zhuchui, CastSpace's Kinetica 2, Galactic Energy's Pallas 1, and Deep Blue Aerospace's Nebula 1. The Tianlong-3 is nearly identical in size to the Falcon 9, with a similar but slightly lower payload to orbit. The 9 Tianhuo-12, or Skyfire engines on the first stage, can produce up to 8,000 kilonewtons of thrust and, just like Falcon 9, burn liquid kerosene and liquid oxygen as propellant. Like many of the new rockets due to make their debut this year, the Tianlong-3 is designed to be reusable, though not for its first few flights while the vehicle and its systems are proven out. We can expect to see attempts at a powered landing sometime next year, all going well, and a maiden launch from Jiuquan, most likely now in September. Now we'll take a look at some other stories across space. Starting with Aerospace, which has been awarded a contract to deliver key components for spacecraft that will dock at the International Space Station. The contract was signed this week with Mitsubishi Heavy Industries and will deliver components that will eventually be used by Japan's space agency, JAXA, on future missions to the ISS. These components include a passive common berthing mechanism, or PCBM. This is an important part that enables the reliable, precise, and secure docking of pressurized vehicles to the space station. It's a fully passive assembly that will complement the active system already mounted on the station, designed with minimal moving parts. Sierra will also deliver a connection hatch for entry and exit, as well as a lighting system and pressure sensor technology. The hardware would be integrated into future craft, such as cargo vehicles, and aligns with the common berthing mechanism. This is a US-developed standard for spacecraft or modules that would berth at the station using a robotic arm to attach them rather than through automated docking. Mitsubishi has also developed JAXA's next-generation cargo vehicle called HTV-X. It replaces the company's HTV, which last flew in 2020 and also berthed at the station. The first HTV-X is expected to launch in October from the Tanegashima Space Center in Japan. If you're looking for more reasons to smile, the European Space Agency has just what you need. The Solar Wind Magnetosphere Ionosphere Link Explorer, or SMILE, is set to launch in early 2026 aboard a Vega C rocket and has just passed an intense phase of pre-flight testing at the agency's technical center in the Netherlands. The mission is a collaboration between the European Space Agency and the Chinese Academy of Science. It's designed to give us a better understanding of the interaction between the Sun and the Earth, measuring solar winds and its dynamic interaction with our planet's magnetosphere. SMILE will fly in a highly elliptical orbit around the Earth that takes roughly 2 days. At its furthest point, or apogee, the craft will get an extended view of the Earth's north polar regions from around 121,000 kilometers. These latest tests checked there's no crosstalk between the craft's electronics, which might interfere with picking up those faint magnetic field signals. And they also gave it a good shake. This vibration testing simulates the intense experience of liftoff and was followed by some thermal testing in a large space simulator. This recreates the vacuum and harsh temperature changes the spacecraft will experience while in space. With all those tests passed, engineers are expecting to give the science instruments one final check before shipping SMILE to Europe's spaceport in French Guiana for its journey to orbit. Rocket Lab has selected a shipyard that will modify and fit out the landing platform for its forthcoming reusable Neutron rocket. Rocket Lab's 122-meter-long floating platform is similar to the drone ships used by SpaceX to land Falcon first stages, but is around 30% longer. It will also feature propulsion systems for station keeping so that it can maintain its position at sea. The platform will also feature blast shielding to protect the deck and other infrastructure from the fury of a Neutron landing. The first vessel, cleverly named Return on Investment, it will be based on a modified barge called Oceanus and will operate out of the US East Coast. The barge will be delivered early next year when construction will begin at the Bollinger Shipyards in Amelia, Louisiana. Bollinger is the largest privately owned shipbuilder in the US with extensive experience in marine engineering. Rocket Lab has plans to quickly scale Neutron and double its launch capacity each year once it enters service. Now, I know what you're thinking, and yes, Sir Peter Beck did once declare that, quote,
marine assets suck,
on an NSF live stream back in 2021. In the fast-moving world of spaceflight, that conversation was a lifetime ago, and long before Neutron was even on the roadmap. We, of course, are looking forward to seeing the first Neutron successfully landing on the deck of a brand new drone ship. The European Space Agency is reviving some old concepts for a new hypersonic test platform called INVICTUS. ESA is eyeing a fully reusable vehicle that can fly 5 times the speed of sound, or Mach 5. It will be built so that parts can be changed and upgraded between test flights. Ultimately, INVICTUS should demonstrate technology needed for sustained hypersonic flight inside Earth's atmosphere. The main challenge for that is heat. Moving at these incredible speeds is hot, as the aircraft and the air it runs into heat up due to friction and shock heating. The hot air also means trouble for the air-breathing engines that power the vehicle, so its hydrogen-fueled propulsion system will be outfitted with a pre-cooler system derived from the SABRE project. That was short for Synergetic Air-Breathing Rocket Engine, and it was originally designed in the United Kingdom way back in the 1980s for a spaceplane called Skylon. Oh, I missed that. ESA is now turning to the UK for INVICTUS. The agency partnered with the UK-based Frazer-Nash, a former car company that is now an engineering consultancy firm. Over the next 12 months, the company will lead a team to come up with a preliminary design of the hypersonic plane. So, even though Skylon never made it to space, unfortunately, the dream lives on. ESA believes the SABRE engine architecture will ultimately enable true spaceplanes that take off horizontally from a runway. We would love to see that dream come true. Over in Spain, rocket company PLD Space is ramping up the development of its Mura 5 rocket. It designed the rocket to carry small satellites into orbit between 500 and 1,000 plus kilograms in mass, depending on the orbit the satellite needs to go to. The rocket's first stage is designed to be reusable, and the company has plans to evolve it into a much bigger vehicle and even launch humans into space with its LINS capsule. But for now, the focus is on Mura 5. The company has mostly been building qualification parts, which they then tested to validate the production process. And they've been doing this for the entire rocket, from tank structures to fairings and even engines. They're now working on the final qualification articles before they're ready to move on to vehicle production. PLD hopes to launch Mura 5 from French Guiana next year and recently signed an agreement to start construction on the launch site. But NSF has also seen some reports that there might be problems with that. Apparently, a rare species of bat calls the place home, and an endemic species of frogs has moved in after the earthworks. These might make it much harder to get legal permission to start construction, but hopefully PLD gets it all sorted out soon. Firefly is making progress towards the first flight of its Elytra spacecraft, which the company offers for a whole range of purposes. The vehicle can function as a space tug to deliver satellites into specific orbits, but it can also host payloads and instruments to be hauled around space to meet customer demands. Firefly wants to launch the first Elytra later in the year, which will perform some demonstrations for space logistics company Xtenti and the US National Reconnaissance Office. To prepare for that mission, teams at Firefly are now practicing spacecraft operations from their mission control. This week, Firefly also announced that it plans to go public, and it registered for a proposed initial public offering. The company said it hasn't decided yet on details about prices and number of shares. Relativity Space has shared a video showing a hot fire of its 3D printed Aeon R engine as the engine qualification campaign passes the halfway mark. 13 of these engines will power the first stage of the company's upcoming Terran R heavy lift rocket with a combined liftoff thrust of over 15,000 kilonewtons. These long-duration tests include gimbaling to control thrust vectoring in flight, as you can see. The full suite of first-stage engine testing will validate the ascent, re-entry, and landing burns, and began in June when the engine was tested for 180 seconds at 100% power. The tests are being conducted on the dual-bay engine test stand at NASA's Stennis Spaceflight Center's R complex. As we reported last week, the design for the Aeon R has now been finalized, and Relativity has begun to manufacture various components for the engines as it ramps up production. Now let's take a look at the space traffic of the week and see what's coming up next week in spaceflight. As always, Falcon 9 launched some internet satellites this week, but only one of them was a Starlink mission. The other carried a batch of satellites for Amazon's Starlink competitor called Kuiper. And that raises the question, why is SpaceX helping the competition? Well, Amazon didn't originally want to launch on Falcon 9, but its shareholders essentially forced it to buy some launches for the world's most prolific launch provider. Plus, SpaceX has been launching internet satellites for other companies for years, so it's really nothing new. We made a whole video about it earlier this week. Check it out if you're interested in the full story. It's a really good one. For some reason, Amazon is still secretive about showing the satellites and their deployment, so we didn't get any second stage views. But weirdly, they did release an image of the payload adapter after all the satellites were deployed. Continuing the theme of secrecy, Falcon 9 also launched a mission identified as Commercial GTO-1. We now know that carried the Israeli Dror-1 communication satellite into space. The satellite was built by Israel Aerospace Industries and is also described as a smartphone in space. We also had a launch from China this week, where Changzheng 7 carried the 9th Tianzhou cargo resupply mission to the Tiangong space station. The spacecraft delivered about 6.5 tons of supplies, including food, science experiments, 2 new and improved EVA suits for future spacewalks, and 1 new exercise machine. Over on the International Space Station, we had a vehicle departure. The 4 astronauts of the Axiom 4 mission said goodbye to the ISS's Expedition 73 crew and returned to Earth in Crew Dragon Grace. During their 2-week stay on the station, they worked on over 60 science experiments and studies. They ended the mission by splashing off the coast of California in the Pacific Ocean on July 16th. Going into next week, it looks like we'll have 4 Falcon 9 missions, 2 from Vandenberg and 2 from Cape Canaveral. One of the missions from Vandenberg will launch NASA's Tandem Reconnection and Cusp Electrodynamics Reconnaissance Satellites, or tracers for short. These 2 satellites will study the Earth's magnetic field and how it interacts with the solar wind. Ultimately, this should help NASA and scientists better understand how space weather affects our planet. One of the Falcon 9 missions from the Cape will launch a pair of communication satellites to medium Earth orbit for the O3b M-Power constellation. The other 2 Falcon 9 missions scheduled for the week are Starlink missions, but you probably guessed that already. Finally, there's a Soyuz launch scheduled from Vostokny. This one will lift the final 2 satellites into orbit for the Ionosphera M constellation of 4. These will study Earth's ionosphere and magnetosphere from sun-synchronous orbit. And that's everything planned for next week. As always, schedules might change, so keep your eyes on our next Spaceflight app and website for all the latest updates. And that's your weekly update of Spaceflight news. I'm Sawyer Rosenstein for NSF, and we will see you all again next week to recap This Week in Spaceflight.